In this exercise, we determine the interiors of some sets. The interior is the set of all interior points. By definition 343, point X is an interior point of a set S if there exists a neighborhood which is entirely contained within the set S. That's illustrated here. With this point X, we can draw a neighborhood around it that's entirely inside S. But here we have a boundary point. And no matter how small we draw a neighborhood around it, there's always going to be some points not in set S inside that neighborhood. So that's not an interior point. A, we have 1 over n such that n is a natural number. And here's the first few members of that set. Notice around each one of these, we can draw a neighborhood around it that doesn't contain any other points of the set. Therefore, these are all isolated points. And inside this set, there are no interior points. So the interior is the empty set. In part B, the union of the closed set 0 to 3 and the open set 3 to 5, we have the half-open interval 0 to 5. Now the interior of this is going to be all the points that are not boundary points. The only boundary is 0, so the interior is the open interval 0 to 5. Around any point between 0 and 5, we can draw a neighborhood around those that's contained entirely inside that set. So all those points are interior. In the next one, we have all the rational numbers between 0 and the square root of 2. Now, every interval contains some irrational numbers, so it's going to be impossible to create a neighborhood around any rational number in that interval that doesn't contain some irrational numbers. So those neighborhoods are not contained in the set the way they are in the diagram. Therefore, there are no interior points. So the interior of S is the empty set. For D, we have the exact same situation. Any interval for a rational number greater than or equal to 2 is going to contain some irrational numbers. So we have no interior points, and the interior of that set is the empty set. And finally, E, when we take the intersection of those two intervals, we get just the point 2. Now 2, if we draw any interval around that, it's going to contain some points that are not in that set. So that's a boundary point. Therefore, it's not an interior point, and the interior of that set is the empty set.